This is lesson 10.5. Apply other angle relationships in circles.
Complete these warm-up problems. For number 1, first you have to find the measure of arc XZ, and you multiply 75 degrees by 2 since angle XYZ is an inscribed angle. And then since the whole circle is 360 degrees, you have to add 110 plus 150 and subtract that from 360 and you get 100 degrees. And these are the answers to the following vocab.
Here's the last slide of warm-up problems. First, you add 110, 54, and 130 and subtract that from 360 to find the measure of AC. And you find that arc AC is 66 degrees. Once you find the measure of that, then you can take 54 plus 66 to find AE, and you can see that this angle right here is inscribed within it. So you take half of 120, which would be 60, and then divide that by 3 to get A equals 20. To begin this problem, you just use the Pythagorean theorem. So you do 4 squared plus 8 squared equals x squared because x is the hypotenuse. Then 4 squared is 16 and 8 squared is 64. 16 plus 64 is 80. So you have the square root of 80, which is 4 radical 5. Then you have 8 plus 4 radical 5 to get your perimeter, which simplifies down to 12 plus 4 radical 5. For this problem, because the diameter is a hypotenuse, you know that it's a right triangle. So to find the other side length, you do 6 squared plus x squared equals 10 squared, leaving you with x equals 8.
For theorem 10.11, if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intersected arc. So to find the measure of angle 1, you divide BA by 2. And to find the measure of angle 2, you divide arc BAC by 2. For number 1, to find the measure of angle 1, you divide 145 by 2 and you get 72.5. For number 2, you would multiply 106 by 2 to get the arc RST, which would be 212. Theorem 10.12, angles inside the circle theorem. If 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. To find the measure of angle 1, you do 1/2 of arc DC plus arc AB to get that measure. For measure of angle 2, you do 1/2 of arc AD plus BC to find the measure of angle 2. For example 3, to find the value of x, you have to do 1/2 of 146 plus 122 to get x to equal 134 degrees. To find the value of y, since this angle and this angle are a linear pair, you subtract 180 minus 110 to find this angle to become 70, and then you add 92 plus y, take 1/2 of that, set that equal to 70, and then you find y to be equal to 48 degrees.
Theorem 10.13. If a tangent and a secant, 2 tangents, or 2 secants intersect outside of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So for this example right here, you have the measure of angle 1 equals 1/2 of BC minus AC. For this one, you have the measure of angle 2. It equals 1/2 of PQR minus PR. For this one, you have measure of angle 3, and then you subtract XY minus WZ, and you divide by 2. For example number 5 down here, to find x, you just take 164 minus 52 and divide that by 2. That gives you 56 degrees. For number 6, you already have the value of the angle, which is 11. So then you just take 95 minus x, divide that by 2, and you end up getting 73 degrees.
Here's a few practice problems. You can check your answers once you're finished. is an interactive site you can go to for more practice. Follow these instructions to practice what you have learned.
Try this challenge problem. Okay, so what you're going to do first is break this bottom part of the cone into two right triangles. So what you're going to have is this is bisected angle right here. So this would be 25 degrees. So you have 25 plus 90 plus x equals 180. So then you subtract that value to get x equals 65 degrees. So to find this central angle right here, then you take 65 times 2 to get 130. And 130 is also this value of this arc right here, as you can see. And then, so this bottom arc is 130 degrees. And then you just use the theorem we've been using to take